Okay, last video. Seems that it only takes it in 15-minute increments. Number 15, I'm looking at all of the different exponents. All of the exponents are 1 for all four factors. All four factors help us determine what the zeros are. Remember, go ahead and change the signs. If it's x plus 2, the x-intercept or 0 is -2. For x plus 1, -1. For x minus 4, +4. For x minus 1, +1. All of these factors, and therefore they're matching x-intercepts, they all have multiplicity of 1 because each exponent is 1. So we've done our x-intercepts. Our end behavior is going to be determined by the degree, which is 1 plus 1 plus 1 plus 1, which is 4, an even number. And the coefficient we don't see in front is +1. So it's even positive. The end behavior of our polynomial is going to be the same as an up-facing parabola facing towards positive infinity. So after I graph my x-intercepts, -2, -1, +4, and +1, I know at the end of each it's going to be facing up. Since the multiplicity is 1 for each of our x-intercepts, that means we're going to go through, come back, go through, and come back up again. So we're going to have a W shape, which you can confirm on your calculator by putting x plus 2, x plus 1, x minus 4, and x minus 1 into y1 in your calculator and hitting the graph button. When you hit your graph button, you're also able to find the y-intercept, putting the equation in y1, hitting graph, and then trace. You can say to the calculator, once you see the blinking cursor, I can plug in 0 for my x value, and after hitting enter, your calculator will tell you what the y value is. The y value is 8, so this is your y-intercept, which you're going to mark on your graph. The last one is number 16 on this page, and it says to us we've got another equation in factored form. The factors are x plus 3 to the second power and x minus 5 to the first power. The degree is going to be 3, which is odd. The leading coefficient in front is negative. So remember, this is the function that we compare to the end behavior of a line with a negative slope. So we know at the end of each of our functions, we're going to go up on the left and down on the right. In between, we have all of our zeros or x-intercepts gotten from the factors. One factor is x plus 3, so as a 0 or x-intercept, it's -3. The other factor is x minus 5. As an intercept or 0, it's going to be +5. And then the multiplicity of 5 is going to be 1. The multiplicity of -3 is going to be 2. So for this function, we go down, we touch, we turn around, and for this one, we continue through this function. So our graph for number 16 should look like this. Again, the last characteristic we need, we have our x-intercepts or zeros, we have our end behavior comparing it to a line with a negative slope. Our last graph feature that we need to complete the graph is the y-intercept. Putting your factored polynomial into y1 in your calculator, hitting graph, and then trace. X equals 0, your calculator will tell you the matching y value is 45. On your graph, you're going to mark that y-intercept as 45. last page. We're on page 5. Now, I don't know why it's not centering. I'll do my best to try to get it to center. Here we go. So I've got a graph. It talks about multiplicity. It talks about degree. And we're going to use everything we can see with our calculator, with our graph to answer the questions. So again, we're going to pay attention to how each of our x-intercepts hits the graph. So we've got 3 x-intercepts. Those x-intercepts are -3, -1, +4. And the first function hits the x-axis and turns around. That happens at -3. So the multiplicity here is going to be 2. That's what it looks like when the multiplicity is 2. 4, where the graph hits -1, you can see that the curve goes straight through it. When the curve or polynomial goes straight through the x-intercept, the multiplicity is 1. For the last one, where it goes through +4, to see that the multiplicity is 3, we see that it looks like a cubic. It goes into the function, it flattens out or zigzags in, and then continues on its way, in this case increasing, tells us the multiplicity is 3 for x equals 4. So for -3, multiplicity of 2, touch and turn. For -1, the curve or polynomial goes straight through. That looks like our second diagram. That's going to be a multiplicity of 1. And the multiplicity at -4 is a curve that goes up, kind of flattens and continues up. That's going to be a multiplicity of 3. We can now answer 17A in our question. The question asks, what's the degree of the equation? Well, if you have 2 solutions, both being -3, one solution being -1, and then 3 solutions all being -4, those all add up to 6. So our degree of the equation is going to be 6. Remember, degree and number of solutions is always the same. I hope that these videos helped you, and I wish you a good night.